Hello, I'm Susan.
And I'm Eric.
And we're educators here at the Museum of Science in Boston in the current Science and Technology program.
This is the Do-It-Yourself Smell Bar, and today we're talking about chemical arrangement. First part of today is our cognitive ramp using Legos, something everyone's familiar with.
Our second section, the chemistry of arrangement, we'll be looking at some soft sculptured molecules here, and we'll be talking about smells. And finally, our Why Do We Care? We'll be talking a little bit about the fragrance industry and the importance of chemical arrangements in it.
So this is the cognitive ramp for our chemical arrangement section, where we introduce something familiar that's going to help our visitors understand this concept. And our familiar topic here is Legos, something that can be built using small pieces. They can be rearranged in many ways.
So in this case, this was a kit that you can buy, or you can just get a whole bunch of Legos and you can put them together to make a truck, or to make a robot, or to make anything that you really want to do. And each of the things that you build is going to have different properties based on which of the element pieces that you're actually using. So the truck rolls, the robot doesn't roll. And if we compare that to using elements, chemical elements, in arranging different types of molecules, well, one of the things that can be different depending on how you arrange the molecules is its smell. So after the cognitive ramp and talking a little bit about Legos, which visitors love to talk about Legos, then we can make the comparison between the Lego blocks being compared to our chemical building blocks, which are the elements like hydrogen, carbon, and oxygen. And just like we can use the Legos to rearrange and make different objects that have different properties, we can rearrange our elements to also make chemicals that may or may not have different properties from each other.
Our example chemicals all have the chemical formula C10H18O. That's 10 carbon atoms, 18 hydrogen atoms, and 1 oxygen atom. And the only difference between the chemicals that we give visitors is that they're arranged differently. Those same elements arranged in a different structure. So we have big examples of these molecules that are soft sculpted. We have fenchol here, which is a lot more clumpy. The molecules are more tightly bound to each other. The other one is citronellal, which makes much more of a long chain. The question is, will they smell the same because they're made of all the same elements, they have the same chemical formula, or will they smell different because they're arranged differently? So then the challenge is to smell them individually. We have examples of each one of these, making sure that we advise again to stay off to the side and give a squeeze and a waft. The fenchol has a much more dirt-like smell.
And the citronellal has more of a, well, if you're first familiar with citronella, like the candles you use to keep mosquitoes away, it's exactly what this smells like.
So they do have different smells, even though they're made of all the same individual elements, because those individual atoms are arranged differently on a molecular scale. So why do we care? The applications of chemical arrangement are really prominent in the fragrance industry. That's $1 billion industry. Imagine all the products you use, shampoo, hand soap. Many of them, almost all of them, have some sort of scent to them. And most of those scents aren't produced by going out to the natural world and obtaining what chemicals we need. They're made synthetically in a lab. For example, jasmine flowers need to be picked at exactly the right time of day. Millions of flowers need to be harvested for just 1 kilogram of the essential oil that goes into making the scent. So natural jasmine scented perfumes are extremely expensive. We can produce a reasonable facsimile in the lab that gets us close enough to that smell for a fraction of the cost.
Now, there's a lot of people who have been baking in our audience usually, and a very common ingredient in baking things, especially making cookies, is using vanilla. So we ask people, do you normally use the actual vanilla extract, or do you use the synthetic vanilla extract? And a lot of bakers have preferences, very strong preferences for one or the other. Now it turns out the vanilla extract, smaller bottle, much more expensive, has 171 different chemicals all in it, all coming from a vanilla bean. Now this only has one type of chemical in it, vanillin, which is what over 90% of the actual vanilla extract is comprised of. And some people say all you need is the vanillin and you get that vanilla taste and smell from it. Other people swear by the vanilla extract and you need all 170 chemicals in order to get the right taste and smell.
So our activity for this unit has to do with smelling lavender. We have one chemical that's natural lavender. It came from a flower. We have another chemical that's synthetic lavender. It was made in a lab, no flowers involved in the process at all. We have examples of these two in smell bottles. So we invite visitors to smell both bottles. Start with one, and then switch, smell the other one, and ask them which one is the natural one, which came from the flowers. So we give them chips to vote with. They're invited to think really hard about which one of those scents, even though they're very similar, actually came from the natural lavender flowers. They'll cast their vote, and then you can reveal which one it actually was. So it's often surprising because people will swear that they know what natural lavender smells like, but will pick the synthetic one instead.
Which one was it?
It was the pink one.
So why do we care?
So this is an example of how chemists, by understanding how to rearrange chemicals on a molecular level, can recreate these scents really faithfully. Not just something that smells vaguely like lavender, but almost exactly like lavender without having to go out in the field and pick all of the flowers individually. So we can surround ourselves with the smells that we really want to have instead of having only perfumes that are extremely expensive.